Hello and welcome back. I hope you've had a good break. I am the session chair and Q&A monitor for the remote part of this afternoon session. And I should note that the lightning talks will be in person, so those will be session chaired and time kept by Willem and Manu respectively. Just as a reminder, for Q&A for the remote speaker, all questions will need to be in the workshops channel, pre-appended with hashtag questions, and will be read out by myself for the speaker to answer. No questions for the remote speaker will be taken at the in-room microphone. During the lightning talks, Q&A will be accepted at the in-room microphone and via hashtag questions in the workshops channel. We'll remind you of these when Q&A starts. Just as a reminder, talk ratings will be in a poll on Mattermost, again, in the workshops channel. And please note that those polls will close at the end of the session, so please do take the time to give us feedback on those. It really helps. And this will be your only opportunity to give per talk feedback. As a reminder, our timekeeper for this afternoon is Pallavi Aras for the remote section. And I'd like to take a moment to thank Ranids and the SOCs as our workshop hosts, and Centre for being the joint program partner. And I'd like to thank VeriSign as the 2022 workshops patron. Our first speaker for this next segment is Zack from Sierra. Jake, are you with us?
I am. Thank you, Hazel.
Great. If you'd like to go ahead and present your slides, and I'll confirm when they're on screen. Great, they're showing up. You can go ahead and start. This is Zack from Sierra with Embracing SLAs, How Customer Requirements Drive Innovation.
Hello, so I am the DNS architect at Sierra, and I wanted to kind of detail both the journey that our organization went through as well as kind of my personal journey when it comes to the share panic that might be created at times with certain RFPs that are put out there or demands that might be put on by the sales and or product team with regards to our Anycast product. So without further ado, I'll jump right into it. So primarily when we're talking about our TLD Anycast SLAs, we're talking about three areas: zone propagation, how long it takes between that first notify and when the zone gets updated on every server in the cloud, DNS availability, how the percentage of queries responded to and or the servers and sites that are up in the cloud, as well as round trip time, both on a regional level and or a global level. So I'll jump right into zone propagation. So it wasn't that long ago that Sierra was a single customer, single tenant DNS organization. We were simply running .ca. In that world, we were unicast. So we had our corporate data centers, which contained our zone publishers and our distribution servers that fired off those zones to our unicast DNS sites. Now, our typical unicast DNS site at the time was a couple of servers with a router in front of it and a single link to the internet. That link was both its management transit and its query transit. There were further iterations where there were perhaps internet exchanges connected to those sites, but for the most part, all zone propagation happened over our management transit. Same with our monitoring. So when we were monitoring zone propagation, we had Nagios. Nowadays we use Isinga. That would send SOA queries across that same management transit to our cloud servers and verify that our zones were up to date in each of our locations. And that was easier then. Because we only had the one zone, we had a very predictable serial number. We knew how often we were publishing the zone. So, a check would be sending a DNS query, getting that predictable serial number, comparing it to the local time of the Nagios server, and letting us know if that alert was greater than a particular threshold. At that point, our on-call team would triage that alert. Generally, the problems that would be flagged there, a missed notify perhaps would stop the zone from updating in a quick manner. Packet loss, at which time we would generally stop the BGP advertisements and pull that site from the cloud. But again, in the unicast world, especially in the early days of unicast, there weren't really BGP advertisements. That was static routed. So, in that old mindset, if one of our 6 unicast DNS nodes are down, it is what it is. The others will pick up that load, and most recursives out there will not even notice that problem really. And of course, if the transit's down, especially in those sites where we did have a connection to the Internet Exchange, we were now in a situation where we weren't able to manage that server. I recall times, 10 plus years ago, where we would, call the data center and have them pull the power because we couldn't reach the machine over management transit, just to make sure that we weren't serving stale data over the Internet Exchange. So we've moved now into a new mindset where we have, a plethora of TLD customers out there. That means that we're getting the zone from their customer distribution servers into our multiple corporate data centers where our distribution servers live, and then sending it out to a much larger cloud with much more servers than we've ever had before. So in that new mindset, perhaps our first few TLD customers were simple. Sierra was new to the game, and zone propagation, while it needed to be fast, there weren't generally SLAs around it. But as we grew, as we got more customers, suddenly there were SLAs. And those SLAs continued to be refined over time, depending on the sophistication of the customer that was coming to us. And at this point, we have SLA for zone propagation that says that we must have all servers updated in our cloud within 5 minutes of that initial notify being sent from the customer distribution server. So again, there were challenges there. The fact that the serial numbers are no longer predictable, everybody is doing their own thing. Sometimes it's, C time, sometimes it's year, hour, or year, month, day, hour, etc. So that has changed that in such a way that it's no longer predictable. We can't do time-based sync checks. We're talking many hundreds of zones. Really, it's over 1,000 zones if you count in the supporting zones, gov dot whatever or .co dot whatever, etc. And because of those SLAs, we need an intervention and resolution generally within 5 minutes of that time frame. So the big thing there is we needed to re-architect things to avoid late transfer situations. And generally, as a rule, you want to ensure that you know about a problem before your customer knows about a problem, so you can remedy that problem and let them know that you remedied that problem well before they noticed and it woke up one of their people. And, as we got further and further down this line of thinking, we reached a point where we realized that we needed to not just alert on these things, but actually in every way, shape, or form try to self-heal the situation as best we could, both to keep my people and my team sane with the amount of alerts, but also to avoid impacting SLAs in a negative way. So our site architecture changed a bit. Aside from the conventional management transit or the management transit was no longer also the query transit. So in each site, we have management transit and query transit. And almost every site, and actually every site, we have internet exchanges. And with our customer demands, we've been forced to set up DMVPN between our locations. Certain RFPs recently have required that zone transfers happen over an encrypted tunnel and that kind of thing. So giving ourselves multiple options here to get the zone distributed to all of the locations has been incredibly helpful in helping us mature our product. I would say particularly one thing that I would look at, both bind and not have the ability to transfer or set a configuration option for v4 query address and v6 query address or something along the source address, sorry. We tend to try to have the v4 address be advertised over a different link than the v6 address. We learned that lesson somewhat early. Having multiple or having both potential ways to get zones going across the same link, the original intention, the management transit, and then eventually the MVPN, proved to be problematic when that link or the link that the DMVPN is relying on is experiencing packet loss, etc. That can be a real problem. So we used the tools within our DNS softwares to ensure that we could get those zones distributed via another method, another route, just to make sure that we have as much diversity there as possible. Now, when it comes to detecting and alerting, we've actually had our customers send notifies not just to our distribution servers or our zone intake servers, but as well as to a notify database, a proprietary mechanism that we set up. And all of our distribution servers, as well as our DNS sites, also fire notifies into this database. So what we have is a method of counting to the exact number of seconds how long it takes for a zone to propagate across our network, from that original notify from the customer all the way to every cloud server we have and when the zone is actually loaded versus transferred. Sometimes there's a bit of a delta between the zone transfer ending and the zone loading. When it comes to detection and alerting, we have a backup method. This uses ingestion of our bind logs into Splunk. So in doing that, we are also able to produce reports and alerts out of Splunk with some added benefit here. So when we see things like connection refused, connection timed out, we stop receiving notifies from a particular customer distribution server, or we see a transfer start but haven't seen a transfer complete in a certain amount of time. Those are things that can trigger alerts on our end. When it comes to I can think of multiple occasions where we've suddenly received a notify for an unconfigured zone from a customer. And as we're sending the email saying, hey, did you mean to send us this notify? They're sending an email saying, hey, we just set up this new zone. So it's just another way to make sure that we are adhering to SLAs in every way, shape, or form. When it comes to our self-healing mechanism, we have this on both levels, both between the customer distribution servers and our distribution servers. And this is generally an out-of-band script. This runs on the server periodically. And, it for every zone we have, it compares the framework or the framing of this particular slide, as you can see, between the customer servers and our servers. We compare to the customer servers via that script in case we've missed a notify, for instance. If we detect that we're out of date, we force a refresh within our distribution servers to try to remedy that issue as quickly as possible, and then spawn a recheck to make sure that we did in fact get up to date. If we get no response from the customer servers, we'll actually do a dig, plus check NS or whatnot, to look at all of the other DNS servers that the customer has published in their NSRR set, to make sure that we are not behind any of those. That can also trigger the refresh. So in doing these things, we make sure that we
Jake,
now we're out of debt. Yes?
5 more minutes till Q&A.
We will hurry up then. Okay, so we do that exact same thing between our distribution servers and our cloud servers. So we have multiple levels of monitoring there. Generally, we know within 2 minutes whether or not a zone is out of date, and we're already working to repair it. The customer generally doesn't know that this happened. It's well within SLA, but we make sure that they are never impacted here. When it comes to DNS availability, again, those SOA queries that used to go across the management transit, we looked at monitoring for Anycast, and we love Write Atlas. It's great. We use it all of the time to check how we are looking from their many number of probes. However, doing that every single minute feels like abuse. So we looked around the industry. Industry leader out there quoted us $10,000 a month, I think at the time, to monitor 4 or 5 of our clouds every 15 minutes. That wasn't quite the granularity we were looking for. So we ended up building our own remote non-monitoring network. This monitoring network has over 100 nodes across the world, generally in places where I can get virtual private servers for under $5 a month. So what we end up with is a per minute accounting of exactly what responded in every protocol, UDP4, TCP4, UDP6, TCP6. And we are also logging, of course, the NSID that we receive for every single packet and query that we send. This allows us to have very granular timing when it comes to the start time and the stop time of any network event. And yeah, so this, as soon as we turn this tool on, and we're using it to also monitor our recursive DNS products, as well as our DOS setup, et cetera, et cetera. But this lets us know almost immediately after any server reboot or any work that we've done, whether or not a server is back in the cloud and responding properly and at the same levels that it used to be. And it's very good at detecting any kind of problems with server transit or IXPs. So when it comes to round trip time, we had to build 2 independent clouds because of GTLD requirements for our Fury registry product. We wanted to have a constant RTT feedback loop. Challenges here is that routing changes all the time, and that Asia is a very, very large place. It's almost impossible, given the way that some networks decide to peer or not peer inside their country based on whether or not they are an incumbent. For instance, China Telecom, generally we're ending up pairing with them in Los Angeles because they don't really pair in so many places inside their region. So these are the Sierra TLD Anycast locations broken down by Cloud 1 and Cloud 2. Customers can request that be one large aggregate cloud. We do that very often now. Key points here, Cloud 1 and Cloud 2 each have consistent transit providers within themselves. I recall earlier in the day when SIDN was giving a presentation about their new Anycast setup. When selecting a cloud provider, very important to have BGP communities enabled there. You want to be able to make sure that you are advertising from the same set of locations across the given cloud, and Equinix Metal does a very good job of that. So kudos to them for that. Our overall strategy is to never have traffic crossing oceans, minimizing RTT at all the time. These are about 3 or 4 years old, but this hasn't changed when we check in Write Atlas. If anybody has any pull with Write Atlas, I would love to see this functionality back. It was the most useful thing for measuring Anycast performance in my mind. The new traceroute system, not so great. What you're wishing to avoid is this. These are each organizations that have been in the Anycast business for 15 to 20 years. Some of them have 30, some of them have 70 sites, and yet a large amount of traffic is crossing the Atlantic Ocean. We have European traffic going to North America, North American traffic going to Europe. Again, consistent bandwidth providers inside a cloud is absolutely ideal. So when it comes to our IXP considerations, we're looking at the internet exchanges with the largest number of peers. Locations with multiple IXPs inside the building. Peering DB is great to find this kind of information. In London, we have Links and Loan App. In Frankfurt, we have D6 and NLIX. Stockholm has 3 IXs. We would have been at 5 if Russia hadn't invaded the Ukraine. So give yourself expansion options is my key thing here. And I would love to see people make a greater effort to not just pair with route servers, because some of the major players out there will not pair with route servers. So that would get more traffic in. And I guess just know your strengths and weaknesses. So we've developed a little platform where we're using data from RIPE Atlas that we collect regularly. We're cross-referencing that with the APNIC ASPOP population, amount of users in every ASN in the world. And then we cross-reference that with peering DB for each ASN. So I can tell you, I have a list of the next 10 locations and internet exchanges I want to be in, because I've filtered them to the top based on how many networks have subpar performance across the world, to make sure that we are prioritizing and putting new servers in the most impactful places. So where we stand today, we're running approximately 1/3 of all the TLDs in the root zone file. That's 448 total top-level domains. I think last time I checked, there were 1,501 or 1,503 in the root zone. That's 36 CCTLDs. By the end of next week, I think we're adding another 6 TLDs. We're doing about 51 billion queries a day average, which I was shocked when I heard, I think at the last OARC, one of the root servers saying they were in the 40 billion range. And I couldn't believe that we were handling as much as, or potentially more, as a root server. And over 65% of our traffic is over internet exchanges. We have over 8,000 IPv4 peers. I've made it a point to make sure that our network team is constantly tending that garden, collecting, every peer they can, like Pokemon, at least the ones that make sense. You're not trying to pair with people that are entirely out of region where it wouldn't make sense, but we do that analysis constantly. All right, any questions?
Thank you, Jake. We probably only got time for 1 or 2 questions, but if people could post them in the workshops channel pre-appended with hashtag questions, and I will read out the first 1 or 2 depending on time. We have got, let's see, just scrolling to find where the question starts. Does the force refresh require that the serial has changed in the right direction on the master server? Slide 12. That's the comment from Matt Stuffberg.
Yeah, so the forced refresh, it does the refresh. It then compares whether or not it has updated to the latest serial. Now, we have some customers that are producing dynamic zones that are sending us 4 or 5 copies of their new serials per minute. In the case of those, we had some amount of false alarms due to the high change rate. So what we've done is for each domain or each zone, we have a threshold timer where we can suppress that. So we can say, as long as the zone has updated in the last minute or 2, and it's within this serial range, then it's okay. So that will suppress that alert from going out in the middle of the night. And that's been working for a few months now very well.
Great. Well, I think that's all the questions we have time for, as we're running a little late with this particular talk. I'd like to thank Jake for that talk, and note that there will be a 5-minute comfort break before the lightning talk section of this session. And for that session, Willem will chair and Manny will be the timekeeper. Thank you very much.
Thank you, Hazel.
See you all in about 5 minutes.
All right, welcome back everybody. I will be the session chair for the lightning talks, which will be the next 25 minutes. We had 4 submissions. I refrained from participating in selecting because I submitted 1. And accidentally, that was one of the picked lightning talks for this session. So I will no longer cut into my speaking time and start presenting. If you, yeah. So this is about DNSThought, or brushing it up, actually. So, DNSThought is the result of a hackathon project, the DNS Measurement Hackathon, which was held in April 2017, organized by the RIPE-SC. And the goal of this project was to provide insight into capabilities of caching resolvers. It was first presented at the combined ORC 29 and Center 39 technical workshop in Amsterdam in October 2018, during the exciting sign and key rollover period. And so what sort of things does it measure? Well, it does basic measurements like IPv6, TCP, and at the time we also added, just before the rollover, for example, the Trust Anchor root KSK Sentinel record, or support of that record, and also monitors things like QNAME minimization, or the opposite, if a resolver supports EDNS client subnet, and then how, if it adheres to the ECS/0 feature. And recently in January, we also added route origin validation for IPv4 and IPv6. So this has been useful for ourselves because for me actually, been using it in research papers and in collaborations with other people that want to look into things. But I think it can also be useful for you, maybe not per se to give a realistic representation of how all the features are available on the internet, but it has a unique perspective, DNSThought, because it uses RIPE Atlas probes. So RIPE Atlas probes also see the IP address of the, or you also have the IP address of where the probe resides, and also of its configured resolvers, because it just gets those from DHCP. And you also see the results of all the queries you're doing, and you can query for anything, for weird types and all those kind of things. So, for example, it's possible to associate the IP addresses at the different vantage points, and in that way make a distinction between internal forwarding and external resolvers. But, so this is the, one of the graphs from 2018, October, showing the amount of internal forwarding and external resolvers. And so at the time this was fine, but I took this graph yesterday. So, you know, you can see it, that the DNS is moving towards more centralized resolvers. But you cannot read basically what happened when exactly. And maybe for this specific feature, that's not really an issue because the trend is more interesting. But here you have something that happened with Cloudflare and Google that did some crazy things with ghost DS validation and support for ED25519. And that now looks like this. And there can be even smaller incidents, which, you know, so this is quite, become quite unusable at the moment. And so, oh yeah, and also the user interface that came out of the hackathon project is quite horrible. There's a selection mechanism of mechanisms that even I don't understand anymore. Yeah. So, so NLNet Labs, actually, without informing me, requested or applied for the RIPE-SC Community Project Fund to do something about this. And so we received some money and invested or are spending this on a professional data visualizer, Roxana Torre to be precisely. And so I've been in discussion with her, and that's exciting and nice. And we are discussing about how would a good interface for this project look like. So just before I went to Belgrade, we were discussing, well, maybe you should have a first page, have an overview of all the different properties, and then you could select a few, display those on a separate page, and then on that page, select a different property and make columns for what that means for that specific property. So I think that's an interesting idea. And also Wipe Atlas in result processing actually had a bug, and I asked about it before, but they said it was my software. And then someone from that worked on Wipe Atlas came work for NLNet Labs, and I said, no, I think it's Wipe Atlas after all. So in the interface, so for the bug here was that this is a measurement that takes in all the new Wipe Atlas probes if they come, but it didn't do that. So what you see here is actually the rate in which Wipe Atlas renews probes, which is interesting in itself, but not what we try to measure here. So the user interface has this button percentages without remaining resolvers, and then that's all smoothed away. And you can see that QNAM minimization is still on the rise slowly. So yeah, that's it. So I present this here because maybe you can think about, if this is useful for you, what would be the best way to present these results? And so I'm actually asking for feedback to try out this link and tell me if it's useful for you and how to improve. And if you have ideas for new measurements, then I'll take those along as well. So send it on to me, please. So that's my talk. The next speaker is Balint Csergo from Meta. Oh, are there questions? I have the... Okay. Oh, thank you. So next lightning talk is Balint Csergo from Meta. He is introducing the DNS-Rocks Meta authoritative DNS server, which I believe will also be open source. So that's great.
So, hey guys, my name is Balint. I'm a production engineer at Meta, and I would like to talk about how we do DNS there, what road we took, how we ended up here, and also at the end I would like to make a very important announcement regarding DNSRocks. So this is going to be an agenda. You can find some pointers in there already. First, I will talk about history of DNS at Facebook or Meta. Then that history will include a bit about tiny DNS. And then DNSRocks, how that came to be, what development steps we took over the years when we have been working on it. And you can see the final point is that we plan to open source it, and it's going to happen very, very soon. So, history, right? What do we need from a DNS server at Facebook? Well, we do multiple kinds of maps. One is the resolver IP-based one. The other one is the DNS client subnet-based one. These are views. We need these views to be simple to be generated from code or by user. We need the server to be easy to be configured, also by automation or by users as well. And it's very good if these changes are easy to be deployed to the servers running the DNS server. Also from the observability and monitoring view, query logs and health metrics are very important, and we need a server that can respond to the requests reasonably fast. From current measurements, it's like 1 millisecond or some 1 millisecond on average. So a bit information about how our DNS pipeline looks like. As you can see, DNS records can originate from automations. These are machines, for example, that get regged, and they get regged very, very often. Or the config repo contains the entries that are added by humans. These all go through our DNS pipeline, and at the end, the resulting database is built, which is then distributed using trackerless torrent. Internally, we run unbound as a recursive DNS, and we have multiple instances of DNSRocks running behind it to serve the traffic. So here is a bit of a timeline. From 2012, we have been using TinyDNS, but with some patches because we are using IPv6 quite heavily. We also needed the client subnet location matching and for it to support multiple maps. Then we did something interesting in 2018, and we figured that we'll write our own DNS server because there have been problems with TinyDNS. In 2018, we replaced the database that was shared until now with TinyDNS, and now this year we actually committed to open sourcing it, and we are very close to do that. So TinyDNS, it's simple, efficient, very, very fast. It's easy to configure. The zone format and the database, like the input data format, is very simple. And also it's very easy to work with the CDB database. You just put the database next to the server, you restart the server, and now it has the latest data. But the code was something that not all of us could work very, very easily. For example, myself, I'm not great at C. And there are many people like me at the company who prefer like modern programming techniques. Also, lack of unit test makes the code terribly hard to reason about when it breaks and how it broke. Basically, we didn't like the code quality, and then also the fact that it was single-threaded limited the possibilities. I mentioned that we need the multiple resolver views and the ECS views, and back then when the decision was made, the open source alternatives didn't support them or didn't support them in a way how we wanted it. So we decided to write our own. We decided to write it in Go. We use the DNS library for the protocol support because that's very great. And also we use plenty of plumbing from core DNS because it has a lovely plugin architecture, for example. Go is a nice programming language. It makes it easy for us to run tests, performance tests, generally write well-formatted and easy to reason about code. We have very good unit test coverage, as that was a necessary thing. And we could make it work with CDB, which we already had the existing pipeline about. So we basically reused the same database. We just replaced the front-end server. And we could also roll out using A/B testing. So we replaced certain set of DNS servers with our own one, and then we could see whether it worked, how it worked, and if it not, then we could iterate on that, and we could move over to our own DNS server. But there have been problems with CDB. CDB is great because it's very, very fast. It's a very simple data structure. It's a hash map on disk. You can mmap it. It's nothing complicated. And it also cannot be changed. But it's also a constant database, meaning that it cannot be changed. So every time you want to redeploy it, you need to override the whole database file, which is not very kind on like SSDs. So we needed to store our database in RAM disk, which took a very precious RAM from us. And also the size constraints 4 gigabyte DNS databases are not enough for everyone. So we went with RocksDB after trying to benchmark many alternative database solutions. We figured that we will go with RocksDB. RocksDB is mutable, but it's still very fast. It's optimized for SSDs already. It's flash ready, so we can move back to flash finally out of RAM disk, and the 4 gigs 32-bit hash map limitation of CDB no longer applies. So we ended up writing a CGO wrapper around the RocksDB C++ library. We added multiple backend support, so even you can run the server now with either RocksDB or CDB as you wish, with a command line switch. And we migrated all the tooling that so far used to build CDB files to build RocksDB databases now. So we had to do a bit of a trade-off because constant database is still faster, but not that faster. But on the propagation side, we had a huge win there because we didn't need to rebuild the database all the time. We could just apply diffs on the database that is running on the server. And open sourcing. So as you could see, we have been running this server for a long time internally. This year, we finally got close to be able to release this. We split off all the proprietary bits that make it run inside Facebook. We replaced them with nice open source alternatives. Internal metric collection was replaced with Prometheus one. Logger is no longer proprietary, it's DNSThought. We had forks of certain dependencies. Now we use all the upstream versions of that. It's already being built and tested on GitHub, and the documentation is also available. I would like to thank these lovely people, first and foremost Manu for starting the project, also my lovely teammates in the DNS team and the edge routing team at the company. And time for questions, I guess.
Hello? Yep.
Yeah.
So there are 2 questions and flow coming in. First question is from Shane Kerr. Does DNSRocks support DNSSEC? And will Facebook.com get signed?
It does support DNSSEC.
Yes?
Yes.
And will Facebook.com
DNSSEC, yes, it does support DNSSEC.
And Facebook, will it get signed?
That's a very good question. Or Manu maybe can answer.
I mean, I guess I can not answer the question. There is no plan. Will it ever? Who knows?
Ralph, you can go.
Ralph, you're welcome. Can you go back to slide 3?
Slide 3.
Yes.
Okay. Tell me where
No,
to stop.
one further. That one. So, DNSRocks is an authoritative server. Why are you stashing a recursive resolver in front of it?
We don't do that everywhere. This is our internal infrastructure.
Because, I mean, this will break with DNSSEC.
Yes, this is our internal setup, but we also have a public-facing setup where we don't necessarily do anything in front of it.
So you said the software is ready to kind of be deployed kind of
Yes.
Okay, good, thanks.
You don't need to run Unbound in front. We just do Unbound as a caching and recursor layer internally.
I have online a follow-up question from Peter Mensik on the DNSSEC support. So do you have at least some production DNSSEC signed zones, is the question.
No, I don't believe so. Maybe Manu knows. I don't know about all the zones.
There is no DNSSEC signed zone, at least on the edge side, like on the public side, and neither internally, I believe. I'm not speaking authoritatively. I'm not working in that team anymore, but as far as I know.
Oh yeah, I forgot to mention one thing. It will be open source very, very soon, but it's not. If you're interested, reach out to me on Mattermost. My handle there is deathall as usually. So shoot me a message, and I will let you know once we are finally able to make the repo public, if you would like to test or play with it.
I have one more question on the MetaMouse channel from Zgast. Thanks for thinking of DNSThought. Make sure you update DNSThought.info when you release. So it's more a comment.
Okay.
Okay. Any more questions? If not, Keith, I hand it over to you.
Okay, so we have come to the end of another workshop. There's a few quick wrap-up points that I'd like to do before we finish and release you to the city and the right meeting. So, first up, okay. Just a few comments about workshops. This year has been we migrate everything to hybrid format, so we've successfully pulled off 3 of these. It's been quite interesting to see the various attendance. This time round, we managed 65 people in person and 35 online. So that's it's definitely a trending back towards in-person workshops. But what we have found is it's been a lot of work. Hybrid workshops, also just the generally uncertain and transitional environment that we're doing co-location with other events is proving quite demanding, and I'm concerned that that's been distracting us from some of the other things in the OARC's mission. So we think that, and overall attendance is still reduced. If you look at what we were seeing in terms of in-person attendance in 2020 and before, and online attendance in 2021. So the current plan is to do 2 hybrid workshops next year. We're already committed to February, and then basically review the frequency and format from 2024 onwards. So what we got in terms of future workshop plans, OARC 40, as I say, that's all committed. We will be going to co-locate with Nanog 86 in Atlanta. That will be in February the 16th and 17th. It's not all that far away. So the program committee has just opened the call for presentations. So if it's something you didn't quite get in this time, or you've been inspired by a talk here, then there's your chance to submit that. Future workshops, we will do something during the second half of 2023 for OARC 41. Exactly where we do that will depend on co-location opportunities. There's always an opportunity to support our workshops via sponsorship or patronage or a donation. You can find out more about that or talk to Dinesh. It's now the point where I try and thank everybody. These workshops don't happen without a lot of effort on the part of a lot of people. I'd like to thank all of our OARC members who pay significantly towards the cost of running these workshops, and our supporters. Special thank you to our local hosts, without whom we would not have been able to do this event, DNS and SOCKS. I'd particularly like to thank Ivan at Beotel and SOCKS for providing the connectivity, and Bojan here for running our webcast excellently. Other volunteers, I'd like to thank Maurizio for doing the social media, and also the B team. You've got 4 OARC staff members here, but there's the other 3 who have been working just as hard in the court's back office to make this meeting happen. So thank you to them as well. Outgoing board members. We have 2 outgoing board members that I would like to thank. Jacques Latour, who has served 6 years as OARC treasurer, and Jaromir Tillier, who's served 5 years on the board and is PC liaison. Jaromir was planning to be here, but unfortunately I'm tested with the usual. So unfortunately we're not able to give Jaromir the presentation and applause that he deserves, but they've both done awesome service. I'd like to thank the program committee in particular. I think they put another great program together. A lot of time and effort going into that, not just on the day here and not just reviewing, but all kinds of other work. All of our speakers come here on their own time and expense. And And yeah, I'd also like to thank the hotel. I think they've done a great job in terms of catering and logistics. So, and to thank all the people that I forgot to thank as well, because there's always at least one. We would like your we would like your feedback. So thank you for all the ratings on the talks. But there's also a general event survey which will be open for the next week or so. If you could please do that. So yeah, if you could please just join me in thanking all these people for making the event happen. Yep, that's it. We're done. Look forward to seeing you all in Atlanta.